Are there any questions over the homework? Yes, sir.
38.
From yesterday? Number 38. All right, guys, so number 38. Describe and correct the error in finding the value of c that makes the expression a perfect square trinomial. So what they ended up getting was x squared plus 30x plus 15, yes? Now, what is c? c is equal to what? b over 2 squared, yes? Did they square it? No. So the error in this is they forgot to square b over 2. That's the error. They forgot to square the b over 2 value because they put x squared plus 30x plus our c is going to be 30 over 2. And that's what they wrote. That's fine. But it should have been 30 over 2 squared. 30 over 2 squared. Now 30 divided by 2 is, but we have to square 15, which if we grab the calculator, so 15 squared is 225. So this here is the correct answer. So it needed to be 225, not 15. Yeah, so this here would be the correct answer. You need all of that. 15 squared. Because they forgot to square the 15. That's where the error came into play. Any other questions on the homework? Now, the last method that we have for solving quadratics is the quadratic formula. This here is our general form, the standard form for any quadratic equation, ax squared plus bx plus c. If we took the completing the squared method and applied it to this here, we would get the quadratic formula, which is our negative b plus or minus the square root of b squared minus 4ac all over 2a. That is the quadratic formula. For any value of a, b, and c, where a is not equal to 0. A has to be different from 0. And we get this here. And this works for any quadratic equation. Doesn't matter what the quadratic equation is, this formula here will work for it. And that's really what this is saying here. So if we look at this first one here, the first one on your page, we can use the quadratic formula to solve it. The first main thing is that we need this equal to 0. With any quadratic equation, we need it equal to 0. So we can subtract 5 from both sides, which tells us that we have x squared plus 3x minus 5 is equal to 0. Now again, this is matching up to the general form of a quadratic equation, ax squared plus bx plus c is equal to 0. Now for us, the quadratic formula again is negative b plus or minus the square root of b squared minus 4ac all over 2a. This is the formula. And we're going to plug in the values of a, b, and c and simplify.
So basically just put 3, negative 3.
So we'd have negative and then 3 for our b plus or minus the square root of 3 squared minus 4 times a. Well, a is what? 1, because it's the number in front of x squared. A, b, and c, none of them will have a variable in them. It's going to be a number.
So that'd always be 4 right there?
So the 4 minus 4, yes, because that's part of the formula. It is part of how it works out with using completing the square. times negative 5 over 2 times a. And a in our case is still 1. Because if we just have x squared, the number in front of it's going to be 1. Questions on any of this here so far? So we're good with how we plug this in, yes? Okay, you just need to simplify. Yes, sir. So the first part we have is negative 3. We can drop those parentheses. It's just going to make it negative 3, plus or minus square root. At this point here, I would plug everything that's inside the radical into the calculator. I use the yellow calculator. Either one for this one here. The graphing or yellow calculator will work just fine. I wouldn't put the radical yet, because if it works out that 3 squared minus 4 times 1 times negative 5 is not a nice number, not a number we can take the square root of, the graphing calculator will turn it to a decimal. Which, okay, we can use the yellow calculator. Yeah, so 29. So for this one here, the graphing calculator would have given us a decimal answer out. Well, in that case, why don't we just use the 30xs every single time? Well, if we've seen up to this point, we could have a negative number, yes, inside that radical. Well, the yellow calculator can't take the square root of a negative number. It's going to throw it out as an unreal answer. So you run into case either way. Either it's going to give us a decimal for the graphing calculator, or it's not going to work for the yellow calculator. So we could plug it all into the yellow calculator and see, is it going to throw out an unreal answer, which at that point we have to retype it back in as 3 squared minus 4 times 1 times negative 5 and see what it is and go from there. I think it's a little bit easier just to type it in without the square root, see what the number is. At the bottom would be 2. Okay, we get 29. It's positive. I can type it in the yellow calculator, hit enter, and see that it's still the square root of 29. Doesn't reduce. And that's your answer.
Okay, so I thought we were going to have to plug it in.
Nope, that's it. Now, if it does work out that there's a common factor among all 3 spots, where the negative 3 at, the square root, and the denominator, if they have a common term in all 3, we'll need to simplify that out, simplify or reduce that. If they don't, that's our answer. Questions on this here? I think out of all 3, this is, I would say, the second easiest one to use. Because the first easiest is obviously graphing. We plug it in the graphing calculator and we get our answer. That's going to be the easiest method out of any of them. But this here is nice because we just have to plug it in. So let's look at the second one. So we have 3x squared plus 4x is equal to 10. We need to minus 10. We need this equal to 0. Three x squared plus 4x minus 10 is equal to 0. Bless you. X is equal to the square root of negative b plus or minus the square root b squared minus 4ac all over 2a. This is what we get here. And at this point, again, we need to plug in the values of a, b, and c into the formula. So x is equal to, so we have negative 4 plus or minus the square root of 4 squared minus 4. Well, a is 3 and c is negative 10. All over 2 times a, which is 2 times 3. Questions on how we plugged in the values of a, b, and c? Now we need to simplify, so we'd have negative 4. The denominator, 2 times 3 is 6, plus or minus. And again, the next part I would do is our 4 squared minus 4 times 1, not times 1, times 3 times negative 10. And we get 136. Now we can plug this into the yellow calculator to see if it reduces. And I believe it does. And 136 will reduce to 2 square root of 32, yes? 34. That makes more sense. 2 square root of 34. Is there a common factor between 4, 2, and 6? 2, yes? Now there's two ways we can go about this. One method is I take a factor of 2 out of the numerator. I factor it out. So we would have 2 parentheses, because 2 factored out of -4 is -2. 2 factored out of 2 squared of 34 is just going to be the square root of 34 over 6. Because all I did was pull that factor of 2 out. 2 divided by 6, or 2 over 6. This would reduce to 1. This would reduce to 3, telling me I have -2 plus or minus the square root of 34 over 3. And that would be the final answer. The other thing we could do is divide all of them by 2, because if we see 2 as the common factor, divide each one of those spots by 2. Because our -4 divided by 2 is -2. 2 divided by 2 is 1, so we're just left with that square root. In the denominator, 6 divided by 2 is 3. We divide it out of all 3 spots and we get this here. Now some books, if there was still one of them could simplify, but the other couldn't, we would split it apart, like we had the other day where we had 2 fractions. Simplify the one and simplify the other if we can. I don't want you to do that, just leave it in this form. Any other questions on this here? Do we need to see another type like this here? We feel comfortable with these here?
So it's already here.
We would just plug it in. Now, I want to jump ahead to this one here. Because this should be probably on the back of the first page. Yep, letter C. I think I said that's letter C, isn't it? So for this one here, again, we need this equal to 0, yes? So, what can we do first? We can add 4 to both sides, which tells us that we have 25x squared minus 8x plus 4 is equal to 12x. So now we can start plugging this into the quadratic equation, yes? No, what do we need it equal to? 0. So we need to this time subtract the 12x, which will tell us that 25x squared minus 20x plus 4 is equal to 0. Now we have it equal to 0. Because the only method for solving these where it doesn't need to be equal 0 is the square root method and our completing the square. Those are the only two we don't have to have it equal to 0, but in either one of those cases we need the constant term, and we would work it in a different way. But here, we need this equal to 0. X is equal to negative b plus or minus b squared minus 4ac all over 2a. Now in this case here, so negative b, well that'd be negative 20. So even though the 20 is negative inside, we still take the negative with it. We have the negative and negative. Plus or minus the square root of negative 20 squared minus 4 times a times c all over 2 times a. Now we can do some simplifying. Well, the first one is the negative 20, and negative 20 is 20. 2 times 25 is 50. Now the next part we need to do is to type in what's inside the radical. Our 20 squared minus 4 times 25 times 4. So let me clear that history out. So we'd have negative 20 squared minus 4 times 25 times 4. And we get 0. Now, what is the square root of 0? 0, yes? What would be 20 plus 0? What's 20 minus 0? So really that plus or minus 0 doesn't matter. It's going away because we can't, if we add 0 and subtracting 0, it doesn't do anything. So we're really left with 20 over 50. We could simplify 2. Yeah, which would be 2 fifths. Because we could have gone to 10 and 25, which would go to 2 and 5. Or we could pull 10 out of both and get 2 fifths. Either way works. Now we still have 2 solutions. They're just both 2 fifths. So we have one real unique solution, because we only have one real unique solution. There are 2 of them, just one of them is unique. Questions on this here? Last type we'll look at is this here. And if we subtract 13 from both sides, we get negative x squared plus 4x minus 13 is equal to 0. So the quadratic formula is our negative b plus or minus the square root of b squared minus 4ac all over 2a. Now with factoring, we needed a to be positive, but here it doesn't matter. A could be negative or positive. And again, we're going to plug it back in, so we'll have negative 4, negative b, plus or minus the square root. B squared is going to be 4 squared minus 4. A in our case is negative 1 times c, which is negative 13, over 2 times negative 1. Questions on how we plug this in? Now again, at this point, we would simplify. So we would have negative 4 plus or minus. We would have our square root. And in the denominator, we would have negative 2. Because our negative 4 and then 2 times negative 1 is negative 2. Now again, we can plug everything inside the radical into the calculator, which would be 4 squared minus 4 times negative 1 times negative 13. I tried to, but if I don't do that fast enough, I lose some of the numbers. So we get negative 36. So this is one of the cases we're just trying to plug it straight into the yellow calculator wouldn't work, because the 30xs would throw it out because it's negative. So we have negative 36. Now we can still use the 30xs to simplify this. We just have to do something to it first. We have to pull that negative out as I. And if we do that, that leaves us with what? The square root of 36. And the square root of 36 is 6. Because 6 times 6 is 36. They do all have 2, yes? Now, we don't want the denominator to be negative, so we can actually divide everything by negative 2. What is negative 4 divided by negative 2? Just 2, yes? So we have positive 2. Now 6 divided by 2 is, it'd be negative 3, yes? But we have the plus and minus. So the negative would turn positive. And what would happen to the positive? It would turn negative, yes? So with the plus and minus, the signs would flip. So the positive would be negative and the negative would be positive. So we still end up with positive and negative. If you don't want to ever encounter that and trying to deal with that negative in the bottom of the fraction, this starting equation, we can multiply it by negative 1 and change all the signs, which would have changed it to x squared minus 4x plus 13 is equal to 0. Okay? Now, I'm going to show you this here. So, y equals, because we had negative x squared. See here, it was plus 4x minus 13. This is our graph, and it's way down there, yes? And it doesn't cross the x-axis, does it? Y equals. Now we have x squared minus 4x plus 13. And it seems like this would change it. And it does change the overall graph. It's the opposite. It doesn't change the solutions. It will not change the solutions of what we have. It'll change everything else, but our solutions will stay the same. Does that make sense? So if you don't want a negative showing up in the denominator, make a positive. Change the signs of everything. Divide it or multiply it by negative 1. Any questions on this here? This is the last thing we're going to talk about, is the discriminant. Now the discriminant is our b squared minus 4ac. It's what's inside the radical. If b squared minus 4ac is greater than 0, we have 2 real solutions. If b squared minus 4ac, the middle one, it's equal to 0, we have 1 real unique solution, or we can just say 1 real solution. And if b squared minus 4ac is greater than 0, or sorry, is less than 0, we have 2 complex solutions, or 2 imaginary solutions. And really the value of b squared minus 4ac will tell us all this. Depending on what b squared minus 4ac is, it'll give us one of these 3. And the reason that we have 2, especially for the real and imaginary or the real and complex, is because that b squared minus 4ac is in the radical. And right before that radical is the plus or minus. So that plus or minus is giving us 2 values of whatever comes out of that. So if it's a positive number, we can take a square root of a positive number, which is real. It might be rational, it might be irrational, but we'll have 2 real solutions. 1 real unique, or you can just say 1 real solution, because we already had one case already where this b squared minus 4ac, where we had the square root of 0. That all went away, yes? And all we were left was x is equal to 2/5. We had 1 real solution. Well, unique, because it's still 2 solutions. We have 2/5 and 2/5. It's only 1 real unique. I like adding that unique part because you still have 2 solutions. They're just not 2 unique solutions, where we have 2 different values. And the same is with that plus or minus is true with the imaginary. But when it's 0, adding or subtracting 0 doesn't change the number. We still get the same number. So, and that's kind of helpful because if we look at these 3 here, it gives us an idea of what the solution should be. So looking at the first one, b squared minus 4ac. b squared in this case is going to be negative 6 squared minus 4 times a times c. Because the first part of this that it wants us to find is the value of the discriminant. So it wants us to find the value of b squared minus 4ac. Negative 6 squared minus 4 times a times c. Enter. And we get negative 4. So that's the value of the discriminant. Is it greater than 0, less than 0, or equal to 0? Less than, because negative 4 is less than 0, yes? So that means we have two imaginary, or we could say complex, solutions. And this is all I'm going to want you to find, especially on the homework. This is it. I want you to find the value of the discriminant, the type of solutions, complex, and the number, which would be 2. Because the book would also ask us to solve it, but I'm not going to ask y'all to solve it. I just want you to find these 3 pieces. That's it. Let's look at the next one, x squared minus 6x plus 9. So they just changed the value of c from 10 to 9, which would give us negative 6 squared minus 4 times 1 times 9. And it is indeed 0. So we could type that in exactly as we see it, and we would get 0. And especially with our b squared, that negative 6 squared, you need to make sure you put it in parentheses. Otherwise, it's going to make it negative. Now, since it's negative, we have one, or since it's 0, we have one real solution. We have one real solution. We don't have to put unique, we just have one real solution. I was pointing that out so that y'all know that it is, we still have 2, it's just not a unique values. And lastly, b squared minus 4ac for this one here. Well, our value of b is still negative 6 squared minus 4. A is still 1, but this time c is 8. And again, type it in, see what it is. And it is indeed 4. So 4 is greater than 0, yes? So this here would be 2 real solutions. And that's it. Questions on any of this here? And that's it. And that's all we're doing for today. So your homework is on page 149. 6 through 18 even, and 21 through 24. Now 21 through 24, you're only finding the discriminant's value, how many solutions, and the type. 6 through 16, sorry.
So 21 through 24 just did.
Yes. So you don't have to solve 21 through 24. You just have to find the value of the discriminant, the number, so it's either going to be 1 or 2, and the type, either real or complex, or real or imaginary.